Hello everybody, welcome back. We are going to go over Lecture 9 today, which is a whirlwind tour through JavaScript. So I've shown you last time in lecture number 8 we looked at how to use JavaScript with forms and how forms are running functions when you click on a button, and you can check the contents of the form, and you can have some dynamic behavior occur after you've filled in a form. So now we're going to look at, well, how to make those functions. So we haven't really looked at the programming aspect of it, and I call it programming lightly because it's not hardcore programming, it's JavaScript, which is a scripting language. So it's not a compiled language, but it's very functional, and it works very similar, but not to be confused with Java. Not a dialect of Java at all. The only thing it has in common is the name. So we're looking at the concept of client-side dynamic documents today, and let's see how far we get through this. So JavaScript capabilities, adding content to web pages dynamically after a web page is alter a web page in response to a user action, and react to user events, and then also interact with frames, manipulate cookie files, and all sorts of different things that are associated with it. And I have a clock, so I'm putting my clock out right now. Here we go. Alright, so let's see, what are we looking at then? JavaScript is not Java. It's very similar, but it's a scripting language. See, Java is actually a partly compiled language. You compile it into a .class file, and then you would load the .class file in with the page, and that would be an applet if you were writing an applet code, that is. Which means you're extending from applet instead of extending from object by default. So that would essentially give you programming, and give you dynamic behavior via a program. But this is actually mixing in the dynamic behavior with the HTML code. So it's more integrated, which is why it's considered partly a scripting language for functionality. So we write scripts to perform different things. The syntax is very similar. It's a subset of Java. It's an interpreted language by the browser. So the browser support is what's going to cause most of the problems. So when you write a JavaScript function and the user says, hey, it's not working, well, it's probably because maybe they're using an older version of Java that's enabled in the browser, an older browser, or maybe they don't have it installed, or maybe the browser behavior is doing something odd to prevent that behavior, that script from running. Because for some strange reason, it's sort of counterintuitive. Antivirus programs love to turn scripts off or warn you if there is a script, like a script is all bad or something, when scripts are actually good. So that gives you the dynamic behavior. So it's sort of, there's a lot of things working against you when you start looking at a scripting language. JavaScript is object-oriented. It uses objects, but it doesn't really support the creation of new object types. But we can create new objects, new strings, new numbers, and new stuff. And we'll see that as I go through the lecture, comparing the... In terms of the object orientation, I wouldn't call it a fully implemented object-oriented programming language. I'd call it an object-oriented scripting language. So it does support object concepts. So the language elements that it contains: variables, literals, operators, control structures, and obviously objects. So I'm going to go through each one of them, and if you've never had a programming course before, you'll appreciate this. If you have, you'll be wondering, wow, man, it's a repeat of some basic concepts you're probably familiar with. But there's some people taking the course that aren't programmers, that don't know anything about programming. So we're going to start from the basics. So what are we looking at here? We've seen this already. So more JavaScript basics. So we know we include script language equals JavaScript, and that allows us to include JavaScript sentences, syntax with our HTML page. And we've seen this before too, document.write. This is considered JavaScript actually, although it's using the document object model. The object is document. The method that we're running on document is write, which is where we're getting this dot notation. And this is sort of a review from the last lecture that we looked at. The document.write hello world is the hello world version of JavaScript. It's putting hello world on the page. And it's mixed in between script opening tag and script closing tag. This is one way of doing it, as we've seen so far, so we can put as many commands inside of the script container as we want. And the right method here writes whatever data we have to the document, allowing it to appear on the screen. So we also know from the last lecture, this is a little bit of review because it's been a week to kind of get you up to speed here. We can put JavaScript in either the head or the body of the document. Even with a write command in the head of the document, the text will still appear in the body of the document because the write is for document. So it's telling you the document body, write this. So it doesn't matter if this is in the head section, it's still going to write it in the body of the document, not in the title bar or something like that, which is where we normally would put things for the head of the document. So we can embed HTML in JavaScript output. So you could put as much or as little HTML code as you want inside of that. So instead of putting hello world in there, you could put, opening and closing bold and underline and a bunch of other stuff inside of there, because JavaScript recognizes HTML code. HTML code only recognizes JavaScript code when you include the script, opening and closing tags, or you import the file in, and then the file becomes part of the main document, which we've actually seen in the last lecture. So HTML can be put inside of the JavaScript, and it can be used to mark up the document itself. And you must print the HTML elements. So we cannot just put them around JavaScript commands. We actually have to write them or print them to the screen to see it work. So here's some examples where we have document write with a B for bold, document write hello world, document write closing tag for B for bold. This works because we're putting the HTML tags inside of the string that we're writing to the screen. This doesn't work. So we can't say bold, okay, document write hello world in the bold, because it's not inside of the string, and this is JavaScript. So JavaScript doesn't understand HTML unless the HTML is put inside of strings or something that's being written to the screen. Then it understands HTML. So it's kind of weird, because most people would try to do this first, because why do this document write, right? When you're inside of an HTML document. So instead you would do this as a shortcut and go, oh no, that's not going to work, and see that, oh, it doesn't work. Most likely, if you're not getting the document right to print what it is you think it should be printing, look at the way you've done it. And usually either you've left out a closing bracket maybe on the string, or you've got it set up so you're not actually writing the HTML code in there. Although multiple write commands may be used, HTML will still ignore the different lines and put the words together. So if you want to force a new line to start, you use the break, the new line break. So you use a line break. If you want a new paragraph, you can use a new paragraph, PR. So here's an example. Because document write is going to string things. This is the interesting thing we run into. It's going to string things from all together. Word wrap, essentially. No new lines. So document write's not going to put one thing in the next to the other thing. So if we said hello, comma, how are you, it's going to print it hello, comma, how are you. So the text above appears all in one line. If you want to make sure it's on different lines, then you go BR for line break, how are you, and put a line break in between. This is pretty much the case with all scripting languages. You'll do this with PHP, you'll do this with Perl, with Python, with JavaScript. Every scripting language kind of works the same way. And you can use document write with everything too. You're just writing it to the screen. In fact, you'll find that you'll use JavaScript with other scripting languages as well. It mixes really nicely. With PHP as an example. It's also jQuery and some of the other Java-related scripting languages mix in really well, which is nice. So it's not like the old traditional environment where you're writing it in one language. You can use multiple things to make it work. So JavaScript's really good at dynamic behavior for the client side. PHP is really good as another scripting language, and if you take a web development course, you'll get more information on other scripting languages. But PHP is really nice because it's on the server. Doesn't run on the browser. So if you have a PHP script that's connecting to a database that's serving up information for the client and delivering it in an HTML format, you're going to need to use JavaScript on the client end for the client to interact with the script. Or you keep having to go to the server, run it on the server, and it wastes a lot of server energy to keep running client-related stuff on the server. So you'll use JavaScript. And JavaScript runs from the client side in the client browser. Doesn't take up or eat up server resources. Eats up your resources on your computer. So we don't care about that. We just care about the server staying up. So I don't know. It's a balance between the scripts. Makes sense in terms of creating some interesting functionality. So let's talk about programming. It's not too hard, actually. What's a variable? Variable holding data. So a variable is a name storage spot. We have variables in JavaScript. We can store information. It's like a little box where we can temporarily put information, and variables have names, so we call the information by its name. First name, last name, date of birth, anything we're trying to keep track of. So they're useful for programming, allows you to retrieve information from the user and use it at a later point in time. So we can prompt for and then store the information from an input, which we've seen already. We put in, enter in your first name, and then the variable is going to be equal to the prompt, enter in your first name. Take that variable, and then we can print it out to the screen. Hello, first name. And then we can have some dynamic behavior. So in order to prompt the user for the information, we can use a prompt, as we've seen so far. Not necessarily the best approach, as we've seen actually as well, because it puts up a little prompt window. Your browser is not going to block that. Your browsers, most of browsers today, however, are going to block windows. So if your window is bringing up another window, not going to work. Pop-ups, ever heard of the pop-up blocker? Unfortunately, people abuse the concept. So now we don't have prompts in regular applications that would actually use them. So instead we have prompts, which is going to be the little itsy-bitsy little window that's going to come up. It's going to say enter in something. Those are still allowed. So you can store the result of the prompt to a function in a variable, and the information entered in by the user will be stored in a variable name and used at a later point in time. So prompt and storing, here's how we do it. And what I'm going to do today, I've shown you the concepts. What we're going to do today is go over the code, how to write the syntax for this. So in order to do this, we first have to create a variable. And we can do it this way by going var space name. And for those people who know how to program in other languages, right now you're struggling with, what about the data type? How do we know it's a string or a float or a double? No data types. Well, there are data types, but everything is loosely typed, not a strongly typed language. So we don't have to go string space name, we just go variable. In fact, we don't even have to do that. But it's proper to, if you're going to use a variable throughout the code, then identify it up front. Say, hey, variable name. So we use var to say we want to use this as a variable versus function, which is another option that we can do to create a function. So where variable var tells us that the variable is going to be a variable and that the name is the name of the variable. So there's now a spot on the computer that's going to hold the information, and the information is called name, which is the name of the variable. You see the semicolon at the end? That's very programming-like for people who are familiar with programming. And then the next line of code underneath it is going to be name is equal to prompt. Enter your name. So the prompt is going to return a string value, and the string value is going to be assigned to name. We have that semicolon at the end. So once we declared the variable, we can assign it to a prompt. This is a variable assignment. Name is equal to. If we put the two equals, we have to do a comparison. This is an assignment statement. So we'll take the information from the user and we'll store it into the variable name, and we'll be able to access the variable at a later point in time, retrieve it by the user. And this is how we access it. So if you want to use the information that's stored in the variable, you just use the variable name. So you do this by going document.write name. Automatically it's going to be stored as a string. So if you use it like a string, it'll be treated like a string, it'll print out like a string. So this will print out the name. So what we do is we don't have to use the quotes. If we used the quotes, it would actually print out name. Well, we don't want name, we want the variable name. So you get rid of the quotes, and then all of a sudden you have the variable instead of the name. So if you use the quotes, the computer's going to think you want to print out name. So just use name, and you get whatever value is stored for name as a variable. So here's an example of printing it out with our hello world. So we have our opening JavaScript tag for our scripting language, variable name. Name is equal to prompt, enter your name, document write hello, comma, document write name. So it's going to say hello space Barbara, or whatever name I put into that little prompt box. Simple, quick, easy way of getting information. More about prompting. So what if we want to change the style of the prompt? We can do that. We can use the prompt function. So we can also enter default information into the field. This is done by using the second parameter. So prompt question. It's going to print up a little prompt, a little question mark. Oh, default text. So you're going to put in there, give me your name. And then you'll have a little box that says, put your name in there. So the default text will appear in the editable field where the user is supposed to put their data in. So default text is going to be enter your name, which a lot of people do that. You know, you see these text boxes and it says, put your name here. Or city, comma, state, you know, if you're searching for something. Which makes it more dynamic and makes it more user-friendly. We also have multiple variables that we can use. So you can use multiple variables with JavaScript. There's actually no limit. It means you can be able to handle multiple different inputs from users. So once we have the access to the different variables, we can use them any way we want to. So it's important to point out that variables can be used as many times as needed as well. And here's some examples. So we can declare multiple variables in two different ways, one per line, or we can put them all together. So this is the same thing you get actually in other programming languages. So variable first name, variable last name, two separate lines, or you can go variable first name, comma, last name, comma, string them all out. You'll commonly see it done this way because basically the programmer will decide these are all the variables I want to use, let's declare them up front and say here they are. So it makes it easier to find them in the code. So we can retrieve multiple pieces of data. Here's an example of that. Variable first name, comma, last name. First name is going to be equal prompt, enter your first name, enter your last name, document.write first name, write space, then last name. Otherwise it's going to put it back to back. So we put this right in the middle so it says first name, space, last name. So you can do this for your GPAs if you want. In fact, one of your assignments is going to have the user prompt in, say enter in all the grades that you got for all your classes and stuff. You can give them multiple prompts if you want, or you can give them one line and then you split on the line to make it out into take all that information, split it out by the spaces, and then put them into variables, and then use the variables any way that you want. So variable naming can be assigned any different names for different variables, helping you to keep track of the actual data that's stored for each one of the variables. It's important to choose appropriate names. We've seen in the examples first name, last name. There are a few naming rules that we could follow. Here are the naming rules. Names can be composed of letters, numbers, and underscores. Names cannot have spaces or special characters in them. So a lot of people who are Windows people like to put spaces and everything. You know, my document, my space documents, stuff like that, not going to work. In fact, it's not going to work with directory structures either, by the way. You cannot have spaces or special characters in the names of your directories if you're going to use them. You have to follow the Unix pattern that doesn't have long namespace. So, but names cannot start out with well, they can start out with numbers. But that's a bad practice. You want to start it out with a character to begin with, no spaces, no special characters. So you can start with a number. It cannot start with a number, excuse me, and names are also case sensitive. So first name with a capital F and first name with a lowercase f are two separate variables, actually. This is kind of the naming standard that you find in other programming languages. So apply, if you know another language, apply what you've been familiar with, and then you'll see how it works out. Here's some examples here, and some of them, actually, we have variable first name, last name, first name, last name. So we have the underscore here separating them out. I don't see camel case in here. This is wrong, but name one works. So some examples of some proper names. Just remember, you cannot start out with a number, so this one is wrong, and then this one here is wrong because it has the ampersand in it. This ampersand was actually going to cause you problems with HTML code. Because you have to think JavaScript has to be compatible with HTML, and if HTML is using special characters, and you put those special characters in your variable names, you're going to confuse the browser, essentially. You're going to confuse the interpreter who's trying to read that stuff. Strings. So we can store strings. So strings are words in the variables, such as first name and last name. And the pieces of information where we have a collection of characters that all get packaged together, so we refer to these as collections of characters or strings. So string is any collection of characters that we find on the keyboard. So in terms of storing numbers, we can also store numbers in our variables. So in order to store numbers, we have to tell the computer using JavaScript that the data stored in the variable is a number and not a string. That's where we convert the string to a number when we want to use it as a number. This is what you'll have to do for the GPA program, by the way. So if you do not tell the computer that we have a number, it will treat the digits like a string because everything's a string. So here's some examples here. So we have value representation. So in order to tell the difference between the strings and the numbers, we show our strings surrounded by quotes. And the quotes often are used to represent strings. So number is equal to 45 is a string of 2 digits. Number is equal to 45 is the integer 45. So when we don't use the quotes, we end up assigning a number. We still may actually have to parse it to a number in order to do an arithmetic expression on it, to explicitly tell the interpreter we're treating this like a number. Otherwise it will treat it like a string. So reading input. So when we prompt for information from the user, it's always stored as a string. So when you say, give me your GPA number 1, and you put in, I don't know, 4.0, then it's going to come out as a string 4.0. That's why you have to parse it to an integer, or to a float, or to a double, depending upon how you're going to use it. So some math operations might work with variables, but not all of them, actually. When in doubt, the computer will treat the number as a string, so convert the string to numerical values. And here's some examples. We have numerical types. Don't have too many types. We have 2 different types. We have floats and integers. A float is a number with a decimal point, which it can be used for doubles as well. Integer is a whole number, no decimal points. It's no precision. So if you want to convert a string to a number, you have to decide which numerical type you're going to convert it to. And then here's your parseFloat, parse integer that you're going to use in one of your assignments to actually convert that string to something that so that you can use it. So in order to take the strings to a float, use the function called parseFloat. Here we have the word parse. Parse is actually used parse string, parse float, parse integer consistently among all the different functions. However, there are different function calls, and they come in together packages as different words. You can't just say parse space something. You have to use the name of the function that you're going to run to parse it. So we parse the numbers from the strings to the variables. This removes the number from the string, storing it as a numerical value. Parse function will also remove any extra characters that we may have happened to have gotten in terms of spaces and commas and quotation marks, and all that stuff is going to be removed automatically. All you're going to get is the numerical value out of it. It does not remove characters that appear before the first character, however. It only removes things after the end. So it takes the trailing stuff and removes it. So here's some examples. So we have variable x and y, and then we have an answer. So x is going to be prompt enter number, and x is going to be equal to parseFloat x. And then y is going to be enter a second number, parseFloat y. And then the answer is going to be equal to x plus y. And then we can print out document.write x, comma, plus, comma, because we want this to come in as a string, y equals answer. So we're mixing and matching strings with integer values in our document.write. We're taking the strings explicitly and using quotation marks to say these are going to be the strings, and we're printing out the variables by just putting in the variable names. So that's kind of a combination of everything we've looked at so far in terms of the concepts. So in terms of our explanation, we can use the variable stored in x and y and create a new variable and stored it in the word answer, which is another variable, and we can use all 3 of them together. We don't have to. We can use the write command as well, and we have the option of including multiple items that we're going to write out with the write command, separated by commas, and here is where we have the commas. So a lot of people would leave out the commas, and then they go, well, what's wrong with that? We're just writing, we're applying, this is a string of arguments that we're applying to the write comment, to the write method on document. So write x, also write plus, also write y, also write equals is how that works. So that's the common kind of thing, is where people just string it together and like, this is the string. It's not really the string though. You're printing out multiple items, you're just having them appear on the screen as a string. So it's a little tricky. There are some people that actually go through the hassle of putting the string together and then writing the string, when you don't really have to either. So there's multiple ways of accomplishing the same task, long story short. So you have to include the appropriate spaces for the output to look correct as well. So what about ints? We can get parsing int, so parseint. And it follows a camel case syntax. So parse is lowercase, the I is capital, and the F is capital in float. So the function will retrieve an integer from the entire entered text. So just as in the parseFloat function. Trailing letters and numbers and things that don't belong are removed, while leading ones cause an error. So if you have a space in front of it, or you have a special character that's not a number in front of it, probably will cause an error when you parse it. So that's what happens when you don't use a split. You just take the character by character and you start parsing it. Then you go, what's the comma? Comma doesn't mean anything, but the comma's right before the number. And then it causes a problem, and then you have to troubleshoot the issue. And then it's like, okay, remove the leading characters, start with a number. So parseInt will remove anything to the right of the decimal point as well. So parseInt versus parseFloat. If you entered in 4.3f as the value into the prompt, then 4.3f will be stored in the variable. So when we use a float, parseFloat, we will end up with the variable value of 4.3. If we use parseInt, we'll get 4. The f doesn't matter. So the f, you can actually assign f as a float, and it doesn't really matter because it gets stripped out in the end. So, what about other math operations? Subtraction works, division works, multiplication works, basic math stuff works. You can apply everything that you know. So you can use these functions to do basic math on your web pages, which is why you're going to do it. Actually, in fact, a lot of basic stuff. From a client-side scripting perspective, do the calculation on the client side. Use JavaScript for it. Don't waste the server energy to do basic math, essentially. So what about strings? You can perform math operations on variables that are numbers, but do math operations work on strings? And do any of the math operations work with strings? Well, they all do. It depends on what behavior you want, though, as we've seen before. If math operations don't work on strings, what the result is what we're going to get. Tells us that we have an error. When we get the not a number comes in. So if you ever seen NaN on a website, it means not a number. So not a number as a result of the equations is not a valid number, which means we try to add a string to a number, and then or we had a blank string and the blank string didn't turn out to be 0 because we didn't parse it, we just took it as a blank when it was supposed to be a 0. And then that's where we're going to get the not a number come out of that. So that's a quick and easy way of testing. And I see it in forums all the time, actually. It's because usually there's a piece of information missing, and that blank space didn't turn into a 0. It is blank. So, and then usually, however, if you declare variables, you can assign them default values and say number 1 is equal to 0, number 2 is equal to 0. Okay, now enter number 1. Okay, now enter number 2. And if the user forgets to enter one in, well, they've both been initialized to 0. If you don't initialize variables, they automatically get initialized to strings. So that's going to cause a not a number if the user doesn't enter something in. It's going to end up being a string. So the plus will concatenate two strings here together. So if x is equal to Bob and y is equal to Bill, x plus y is going to be Bob Bill. So the minus, the times, the divide will fail. So the result of the string will be not a number. So plus is for concatenation. So minus isn't going to do anything for you. Neither will anything else. So JavaScript will give us errors if we try to do something that it doesn't like. So the errors may involve something printed on the screen, might also involve nothing printed on the screen. That's the terrible part to troubleshoot, is when the whole screen comes up blank. It's because your function was malformed or something. Or you ran a function, it didn't exist, so nothing is going to show up on the screen. So you might need to be able to figure out where the errors are and fix them, hopefully. Personal suggestion, write a JavaScript in fairly small logical sections. Test each section to make sure that it works. And then once the section works, move to the next section. Because what ends up happening is if you put it all together and put it in the file and then it shows up blank. You go, what's wrong with this thing? Harder to troubleshoot. It's kind of like writing your entire program and then testing it. And then you go, well, if you write it in pieces, compile, run, test, write it another piece, test, write another piece, test, you have more likelihood of actually getting it to work properly. If an error is introduced, then you'll know which lines of code that caused the problem. It will be the new stuff you just added to it because the old stuff was working. So, hopefully. So if you're unsure about how some piece of code might work, you can look it up online to see how it works. You can write small little programs and see how it works. There's a bunch of testers. In fact, you'll see this with CSS and you'll see this with HTML code as well. W3 Schools actually has a nice little website interface where you cut and paste, you put your code in the window, you press run. It'll run your JavaScript function for you. It'll apply your CSS page to your HTML page. It'll run your HTML code for you and tell you what the output looks like. Not a bad way of testing, actually. If not, you don't even have to do that at all. You just save it, double-click on the file, load it up in your web browser. There's another way of testing it. So it's kind of a manual process, however. There's no compilation, so there's no way of actually knowing if it's correct or not without seeing the results. So by writing code, you can see things work and answer your own questions quickly about JavaScript, hopefully. It's a good way to learn how to program as well. So we have different error types that occur. So there's 3 different types of errors: syntax errors, logical error, and user errors. So with JavaScript, it's actually with forms and with processing this type of information, very error-driven, more so than regular programs, because users will not follow what they're supposed to do. So you have to accommodate for all of the things the user could possibly do to your page in using it. And not only the user, but also now we have to worry about non-users. We have to worry about robots, agents that come through and automatically fill out stuff for you, because their job is to go out there and populate the internet with bad information or something. I don't know what their jobs are, but so you must be able to determine the difference between the errors in order to be able to correct them. So syntax error is an error created incorrectly by typing in JavaScript statements. For example, here's a syntax error. We've left out the quotation marks at the end. So the missing quote will cause a statement to fail. Such statement may simply not work in our browsers. In fact, nothing's going to work. The page is going to be blank. Well, this particular part of the page is going to be blank. Unlike other programming languages that go through and either the whole thing works or none of it works, JavaScript is pieces of it can work and then other pieces of it cannot work, depending upon what's being parsed and what's being run. It doesn't stop. It will stop, however, on some errors that cause fatal, can't render the rest of the page because of this error. That's going to definitely stop and you're going to see a blank page. We also have logic errors. Logic errors occur when you make a mistake with the logic of the statement. As an example, the number is equal to 50 plus 100 divided by 2. Isn't that really 50 plus 100? We want to do this first. Otherwise, it's going to go left to right without any precedence rules. It doesn't know how to do math. It just knows what you're telling it to do. And you're telling it to do it this way. So really you want the second one, but you type in the first one, so you got a logic error. So be careful of logic error in a program. It's probably the worst thing to catch. The worst thing to actually correct. Or user error. User errors are caused by users entering in the wrong information. So you put in a text instead of a number, or you don't put anything in there at all, and then it comes back blank, and then you get not a number showing up somewhere. So if we expected the user to enter in a number and a letter is entered in instead, it can cause all sorts of problems. So there's ways of double checking to see if the user typed in something, help avoiding this problem. This is where the concept of form checking came into place. So form checking is used on everything these days because we have to check to make sure the user put in the right stuff. And now you can actually design the form so it's self-correcting. So the user can't put in a lowercase c and a lowercase a for California as an abbreviation because they have to select it from the list. And the list is going to put the uppercase c and the uppercase a in there. Or you're going to have 3 spots for the telephone number, the prefix, the suffix, and the number, so you're not going to be able to have them enter in a mal number missing a component. Even though you got something, you can actually check to make sure this is a valid area code, this is a valid prefix, and stuff like that. So you might be able to write a program in a couple of different ways. You should choose the method that makes the code as easy as it is to read in terms of readability. So once again, writability. Writing readable code is important. It's easier to read it, so it's easier to understand it and find errors if you can read it. Variables and statements. So you must declare our variables before we use them in a program. It doesn't make a difference whether you declare the variables as long as they are declared before you're using them. So if you start using a variable that's not declared, then you're going to get an empty value that shows up. So in order to make your code more readable, you can declare all your variables at the top of the program. It makes the code a little bit easier to read. So here's our, and this is actually, believe it or not, traditional C-style programming. Declare the variables up here and then use them down here. So don't have to do it this way, however. You can mix up your variable declarations and put them inside of the code, and it will work just fine, as long as you declare them before you use them, or actually I should say assign values to them before you use them. So we have untyped variables, so we can declare variables with variable keyword variable. And we have var foo. They can also be created automatically by assigning a value to them. As I mentioned before, you don't have to use the word var. But if you use var space foo, we know that's a variable. We could just say foo is equal to 1, blah is equal to hi Dave. We don't necessarily have to say variable blah, variable foo. So it can be created automatically as soon as we assign a value to it. So using var to declare the variable results in a local variable inside of a function as an example. If we don't use var, the variable is a global variable. So a lot of people will use inside of functions, will use var to declare the variable inside of the function just in case, and we saw an example of this the last time, just in case we use the variable outside the same name. We can actually have two separate variables, one inside of the function, one outside of the function, because one's going to be local and the other one's going to be global. So if we don't use the var, we're making a global variable out of that, which means we can use it anywhere. Inside of the function, outside of the function, anywhere. So it depends on what you're trying to do in terms of accomplishing it. Literals. So the typical bunch of literals, we have numbers, strings, booleans, arrays. So the arrays can hold anything. So not like typical programming languages where you have to have just one data type in the array. Here we have an array that's holding a number, a string, a float. So we have an integer, a string, a float, all in the same array. And then we have the operators, as we've seen before, arithmetic. We also have comparison, assignment, bitwise, and boolean, pretty much like C. So we have the comparison. Is this equal to this? Is it not equal to, less than, greater than? And the ors, the nots, different ways of comparing. We also have control structures. So again, pretty much like C, we have if, else, and then we have switch. And then I'll see some examples of this coming up. And then for, and then, for or while or do while. And again, a few not like C. For variable in object with object, do something. So we have our traditional style, which most people are familiar with if they know another programming language, and then we have our scripting variants. And scripting variants are very scripting-like. They're very similar to other scripting languages as well. So as soon as you learn one scripting language, then you start seeing the similarities among some of the other ones, and go, oh, this is scripting. This is all the same, pretty much. I mean, what programming language doesn't support if and if else, else's and thens, and or the fors and the whiles and the do whiles? And now we'll see some examples coming up later with these control structures in them. But the concepts essentially are supporting the basic iteration, or as they call it, flow control or control structures. Objects. So an object is a definable thing, such as a car. Objects are allowed to have other objects. So a car can have a trunk, and a trunk can have a spare tire. So since JavaScript is object-oriented language, we use the dot syntax, and we saw with document.write, actually we've seen this already, to specify the relationship between the objects. So here we have car.trunk.sparetire. So spare tire is in the trunk, and the trunk's inside of the car in terms of the hierarchy of those data members. So the objects have attributes and methods just like they do in Java and in C++ and other programming languages. Many predefined objects and object types are already built into the language. Document's a good example of that. Document's an object type to represent the document. So you can do document.close will close the window. Document.write will write something to it. Document.open will open up a new window, actually. So using objects followed by the syntax of C and C++, object name attribute name, object name dot method name. And in this particular case, this is not what I would call very object-oriented like in other languages, because in other object-oriented implementations we keep the data members private. JavaScript, everything's public. So we're using it kind of loosely. We're not following true object orientation in terms of the concept. We're doing sloppy object orientation with JavaScript. So just think it's okay to get at attributes this way. And it's okay, obviously it's okay to run methods. But We have instances that we can create as well. So an instance is a particular, it's an incarnation of an object or an instance of an object. Same thing we get in other languages. For example, we could represent students in the class using class.student, where an instance of the student object would be a particular person. So an instance of the object has all of the same attributes as the object. So person would have first name, last name, grade, or anything associated with the object. So object is in a real life situation. It's a tangible thing, a car, a bike, a computer. And you can see, like in the name of the objects, you can name them appropriately, just like variables, and remember what the object is representing. And the object name doesn't define the object, but it acts as more of a reference to the object itself. So in programming, we use objects as reference names for information that we want to store, and we store them all together. So we use programming objects to store information about real-life scenarios, real-life situations. And we store object data by storing the information about the individual attributes and the properties of the object in question. So let's take a look at some object examples. So we have object information, which is our data. So for example, if we have a green bowling ball that weighs 3 pounds, we know that the bowling ball color is green, that the shape is round, and that the weight is 3 kilograms. Did I say pounds? Okay, whatever. There's a weight associated with it. And in each of the cases, we are associating an attribute with the piece of data that is describing it. Felt something on my leg. I'm like, what is that? Okay. So when creating an object, that woke me up. Okay, so
Halloween special.
Excuse me?
Halloween special.
Halloween
special.
Halloween special for today. Let me spook you out by going, no, I'm freaking out. No, I felt like something was crawling on my leg. I think it was my pants leg hitting my leg, but it was like creeping in, and it just like, oh, it's scary in this place already. It's not even Halloween. All right. Creating an object. So in JavaScript, we can create an object using a function. In this case, we can create a bowling ball. So we can say, or a bowling ball object. So we can say variable BB ball, bowling ball, is equal to new object. So people who are familiar with object-oriented programming languages hate this, because this is just a plain old object. And do we actually create a bowling ball object? No, but we're creating a bowling ball object this way. So we don't have to write the class, long story short. You don't have to create a class for bowling ball and have data members and member functions and define all that stuff up front and then make an instance of that class. Instead, you move 10 feet ahead and you just make an instance of the class. And the class is of type object. So people who don't know anything about object-oriented programming love this because it's easy. People who are familiar with Java or Objective-C or C++, they go, wait a minute. How can you just make a bowling ball? You have to make the class first, class, bowling ball, data members, member function, public, private, protected, and all this other stuff. That would be a full implementation of the concept. This is a partial implementation of the concept. We're just going to make an instance. And all objects are objects. They all fall from the same object type. Hello. So we have... You're just trying to stay awake too. So new object. So variable, BB ball, which is going to be an instance. This is going to be an instance called this, and it's going to be a new object. So the code creates a new object called BB ball. The new object function is called to construct the function because it is used to construct a new object. So just remember new objects is going to be used. And it's an actual function, but we're actually using the word new, which is interesting. So now here's where most people go, oh no, but we don't have, remember we didn't create a class called object. We didn't create a class called object. We didn't create a class called BB ball either, or anything. So we have an object, and we have an object that is called BB ball. Then we can store information about the object. We can say bball.color, and you're wondering, well, where'd color come from? Don't know. bball.shape, weight, holes true, shape, weight. So then people who don't know about object-oriented programming go, wait a minute, you skipped like 5 steps. How can you say there's a color attribute in there? It's on the fly, it's dynamic, you just created it. So what does this solve? the problem of, well, it's kind of like C++ structures, where we have a bowling ball structure, and inside the bowling ball structure we have all of these other little data members, and they're complex. They call them structures complex data types because they enclose a bunch of other data. That's what the object's doing. But the object is enclosing a color, a shape, a weight, a holes inside of the object. So our other instances of other objects, we can use the same format. So we can know that if we're keeping color, shape, weight, and holes for our bowling balls, and we have another bowling ball that we're creating, we can assign color, shape, weight, holes, and something else if we want to. It's dynamically created. We just have to remember what we put in there. So if we can't remember what color is the bowling ball, we can go bball.color. And if we have bball2.color and bball3.color, however many balls we create, we can keep track of all the associated colors with each of the associated objects by making the variable attribute a member of the object by using the dot notation for its assignment. So we can store as much information as we want about our bowling balls the same way. So we have bowling ball color, shape. So in fact, further along in the program, we can essentially take and create more attributes the same way after we've created this ball and we've assigned these to it. So if you like object orientation or familiar with that from a programming perspective, you hate this because it's not quite as, this is way easy, or way loosely implemented, I should say. So in terms of the object information, we associate the properties of the object with the dot, using the dot. This allows us to associate the parameters to a particular object. For example, we can easily store the color of multiple different objects. So using the object name will help us keep track of the information that we're looking at. So here's another example. Bowling ball color is equal to green. Car.color is equal to red. If we want to say document.writeColor, we don't know which color to print out. Same thing you get actually with object orientation. In other languages, you have to say bball.color, car.color, if we want which one of the colors. So think of it as like a hierarchy of variables. So I got variable number 1 is the ball. Variable number 1 dot color, is now the color of the ball, which is really a second variable. And variable dot weight is another third variable, fourth variable. But we're nesting them by the attributes that are associated with the ball, which is sort of what we're doing with data members for objects, but it's used in a slightly different way. It allows us to organize the data. In this particular case, color is being organized by two separate objects. And we can reuse the name color, because this is actually the name of a variable if you think about it. bball.color is a variable. It's an attribute variable that stands for green. So we're really just calling it out and saying print green out here, print red out here. So a lot of people argue and say, well, it's not really object orientation. Well, okay, it's loosely object orientation. It's not true. So object attributes. You can add as many attributes as you want to the object. It's advisable to keep the number of attributes to a minimum. You also need to declare all of the attributes in the same location, making it easier to track them, hopefully, so you know which ones you're looking at. Then we have the concept of primitive types. So considering that an object is a new type of variable, we now can refer to them as ordinary variables as primitive types. So any object that is of an ordinary variable type is referred to as a primitive. A primitive type is one of the regular variables that we can store: a string, a float, or an integer. So there are three primary primitive types: numbers, strings, and booleans, that we refer to when we talk about objects. So we're looking at numbers, strings, and booleans as primary primitive types. We also have compound objects. So compound objects is an object where some of the attributes are other objects. This is where we get the document object model, actually. We have compound objects. So window.document.write. So write to the document that's in the window. Well, we don't have to put window in it because everything's assumed to be in the window. So we have a hierarchy of objects that are nested inside of the object model that gives us the hierarchy in terms of the functionality. For example, one attribute of person object might be their name, and the name itself might be first name and last name. So the name itself is an object composed of first name, middle name, last name in this particular case. So in this case, the object name is the attribute of the object person. So here's what it looks like. So the compound object here, person, so the parent person has child name, it has composite nested object of first, middle, and last, and then age. And everything is an object. So age is an object, name is an object. These are objects inside of compound. So that could be considered, well, this particular object is this particular variable is an object. It's a name. This is a single valued primary. So this is going to be a primitive age, which is going to be a number probably. But in most cases, we'd probably store birth date instead of age, but you get the concept, I hope. So you can compound objects inside of objects. So when using compound objects, you can use compound objects in the same way as you use the variables or the data members. The advantage of the compound objects, it follows the ability of logically managing the object. So you'll be able to store all of the related information in a logical order. So if we wanted to say, we have a person instance, we created vhecker, which is of type person, and inside of person we have name, and name has, so we can go vhecker.name.first equals something. And then we can go person.name.middle, person.name.last. We can get at the different parts that are inside of that particular person. So let's see, more on objects. So we're going back to the document object model. The document object is a compound object. Document object is part of a larger window object. So each of these objects has attributes that we can access. And here's a couple of them I mentioned before, actually, because I sort of talked ahead on this. Window.close, Boolean, true or false. We close the window. Window.location. We can, be tricky and move the window around. Actually, we can take the mouse coordination. Most of you probably have seen these before. They're kind of irritating. When you go to close the button, it moves. So you can't close the button because you can never get to it, because every time you move, the location of the button is moved, because the mouse, it takes the mouse coordinates and times it by 5 or something, so it adds something to it. So the button is always ahead of or behind, over to the left or to the right of the mouse pointer. So it's like, close me for win $1 million. Click here, and you can't click here. So that's actually, that stuff's still around. People are constantly entertained by that. Or what I liked was a little image that's in a transparent background window, but it's an image window. Then the image follows the mouse cursor around. That's irritating as well. So some of these things are really irritating, but you can actually mess up your user's psyche by doing this. Windows.history.length is going to give us the number, how old, what's the history. So the document object, let's talk about the document object. The document object is a special case in the window, so it's a special object, and there's no need to specify the parent window object. It's already given to us. So we just say document. At no point do we ever say variable my document is equal to new documents. We don't have to do that. We just say document. It's given to us automatically. Allows us to use document.bgcolor for background color instead of saying window.document.bgcolor. So in some examples, you'll see it written out this way. Window.document.bgcolor. It's the formal way of doing it. You don't actually have to do that. If you're following the document object model, you can just go document. So there's many ways and many other ways of attributes that can be associated with it. So what you can do is do a Google search on the document object, and you can find all of the different things, all of the different attributes. Here's another sampling, actually. And one of the assignments actually has you do, I believe, the last modified date. So you're putting in here attributes. So you can actually set the last modified date. You can get the last modified date. You can say background color. You can set a string, foreground color, URL, link color, viewed link color. So all of these items, however, are also set by the web browsers. So web browsers in the properties menu can set document attributes. In fact, all of your properties are the document attributes. You're setting the background color, the foreground color, the font size, all that stuff is set through the web browsers. So other methods. So a method is a function an object can use to perform various different tasks. So we have those two components that are associated with objects. We have the data members and we have the member functions, or the methods, I should say. So we have already seen the object method write. So we can do write for document associated with document object. The write method is used to tell the document to add some information to the page. So this is why we say document.write something. Hello world. Methods are powerful. They modify the objects. They create methods for objects that have created is out of the scope of the course. So we're not going to actually create methods for objects. Instead, if you wanted to take a full object-oriented programming class in terms of JavaScript, full JavaScript class, you could write your own methods. You don't actually have to write methods or create objects in this particular class. What we're going to do is use the built-in ones of document, the built-in ones of integers and floats, and all the other types of objects that might exist, because objects are everything. But to take advantage of the methods available to us in the windows and documents and other objects, you write some methods. So let's look at the ones that are built in already. And so, in fact, you can change the methods for your objects actually quite easily. And then if you're going to go that far, you might as well switch from JavaScript and use a real programming language. Because at one particular point, you're going to run into the limitations of a scripting language in terms of the object model. Or you're going to use it like, scripting on steroids, and you're going to create objects with methods and stuff. And it's going to be a lot more work than if you just picked up Java and worked with a true object-oriented language. So in other cases, it's harder to do traditional style programming with a scripting language. That's what I'm saying. So confirm. The confirm method of the window object will ask the user to a question and get a result. So it's either going to be true or false depending upon which button was pressed. So you can store the results of the question in a variable, and you can use the variable later in the program to perform some action. So here's an example. Now we know the pieces, we can start looking at the source code examples. Variable question. Question is going to be equal to window.confirm. So what this is going to do is, this is going to send up a pop-up window. So as I was mentioning before, prompt is going to work regardless. Window.anything is going to cause your antivirus program to go crazy. And that's a spyware program, because it's going to open up a window. And the window, everyone has a bad connotation to it. They say, oh, it's a pop-up window. It has good reasons as well. It's not always to put up a window for ads. Because what ended up happening is people went, window.open, myviagra.com, window.open, buy this junk stock, window.open, all this other crap that shows up. So you go to a website, you accidentally go to a website, and all of a sudden all these windows start popping up in front of you. And then people say, oh, we don't like that. So browser, it doesn't really cause, it's not a virus. It's just commands that are available that people misuse, essentially. So this one's used correctly. This one's going to set up a confirm window. And your smarter browsers won't block confirms. They'll only block open new windows. So it'll, they call those pop-up blockers because they're pop-ups, the pop-up windows. Windows that appear. Some of these pop-up windows take up your full screen, though. So I don't know if the word pop-up is really appropriate, but long story short, confirm is not normally blocked because it's of a special type of window. So this is a question where you have to answer OK or cancel. OK is true, cancel is false. Do you understand? And then here we have an if-else. So this is where flow control comes into place. So we say variable question. Question is going to be equal to this stuff here. So this is going to come back with a true or a false. So if question, meaning if true, and we're using Boolean logic, this is the same thing that applies to programming languages in general. The if-else checks for a true or a false. So if true, because question is going to be true or false, document.write, you understood. And then we have opening and closing brackets to section off the if part. Else, opening and closing bracket, document.write, you didn't understand. Because it's false. Do you understand? No. Okay, so I'll have to ask you another way. So going back to what I was saying before, this is an example of using the if-else, same as you get in C or C++, very similar. So the window.location is responsible for telling the window to load a new web page. That's the pop-up blocker. Here we go. We say window.location is equal to open up the Hayward website or the IT website or anything, any websites will be transported to a home page. because the location of the window is going to be moved. So people like to do window.location to do what's called a redirect. There's also a proper way of doing a redirect. So you go to a website, it takes you to another website. So if you accidentally go to the wrong website, it'll take you to the wrong website again. Or it'll maybe even take you to another website. So spoofing is done a little bit differently, but you could use a window.location to spoof a site. You accidentally typed in something incorrectly, so it takes you to something that is similar, but not the exact site that you were looking for, but it looks like it. So it's spoofing the site because it matched the URL incorrectly, and then the logic of the person who wanted to fool you put in a window.location and sent you to a totally different site. So it looks like the site you wanted to go to. PayPal, there's a lot of people that do that with PayPal. You accidentally misspell PayPal, or you misspell, you know, www.wellsfargo, and you leave out the S in the Wells or something, and it spoofs. It takes you to a site that, not exactly the site you were asking for, but it looks like a Wells Fargo site. It's an imitation. So you can, you know, enter in your account number, enter in your social security number, enter in all your private information, and it just gathers it for you. And it says, oh, sorry, you're at the wrong site. Go to the right site after you've given all your information away. So it's just a trick to sell you something, to take your money, to get your information. So, but unfortunately, it's good used for good things and for bad things. So location just changes where you're pointed to. History is going to be used. Window history is going to go back to the previous web pages. History is kept in a cache, and so you can go back, forward, and for navigation. So you can keep track of the histories. For example, if you want to bring the user back to the page that you just arrived to, you can use the window.history.go -1. If you go window.history.go -1, it brings you back. So if you've ever seen those websites where you're trying to go forward and you're trying to go back, you hit the forward button, you hit the back button, and it just doesn't take you back. It's because they've played around with the window.history to make it so when you go forward, you're going back. And when you're going back, you're going forward, which means you can't leave the page. It's another trick for people to keep you on the web page. So you actually have to close the web browser window and open it back up again to navigate somewhere else. So I hate sites that do that, but some legitimate ones actually do that because they don't want you to navigate off the site. So it's a ploy to keep you on their website as long as possible. Make it so the forward and the back button don't work. All you're doing is inside of the web page, you're playing around with the window.history properties. Window.history, go current, and you put it in a loop and it just constantly stays on the same page. So you can't navigate off that page. Not such a good thing. So you can go back many pages as you like if you have it set correctly. Properties. So objects can have properties. These properties are responsible for identifying and storing the information about the objects. For example, the example I gave you earlier, class.student has instances of students that have a property called name. So you can access the property using the dot syntax. So class.student.name is going to give you the name. So here we have values that we can assign to the properties. So you can set the value of the object property for the instances of the objects. So in our student example, we can set the name of the student to class.student.name is equal to Frank. Likewise, we can apply this to our document. So window.document.background color is equal to red. So we can set that. And all of this stuff we can set when the page loads, when the page unloads. In fact, if you do on a page unload, set the history to go back -1, it tries to unload the page, but it's going to go back forward. So it's overriding your back and forward button, which is how you would actually do that. If you wanted to implement this irritating functionality on the page unload, have the history go back 1. So it's not going to unload. So accessing the values. If we include an image on the web page and we give it a name, we can access it as a property, which is why you can hover your mouse over and then change the images on a web page, because they are, as an example, image source is going to be image.jpg in terms of the image that we're doing. The name is going to be testpic. Alternate text is going to say picture if the image is not available. So we can go document.testpic.source is equal to image. So when we click on the image, we can say document.textpic.source is equal to. So depending upon the event, we can change the images. hover over the image, take the image and highlight the image, which is you're taking the image and replacing it with another image that looks slightly different. You're not really highlighting the image, you're replacing the image. But it's dynamic behavior that can be performed for the mouse movement. Change the image, have the image location change, which is how you're going to get the image to follow the mouse. Actually, you can create a really irritating web page where all the images come up and sit next to the mouse. You've seen that, actually? It reminds me of that Wii game when you have the, you guys play Wii, you have the Mii's, and you can line the Mii's up, and then you can have the Mii's gather, and then you can, it's a bunch of images of avatars for the players, but you can like play around with the Mii's. You think, why are you going to do that? Because it's fun. So people do all sorts of things on web pages because they think they're fun. So, in terms of accessing values, so here we can access the value of an event. This is going to come in handy with other scripting languages as well, because you're going to have a PHP script or something where you're going to want to say, well, document.testpic.source is equal to this now, because the user did that. And inside of the function, you can put, let's say, for example, inside of a PHP function, you can write a JavaScript code. Here's JavaScript. It's going to change the image to something else. Likewise, if the background color of the web page to gray, you can say body BG color is equal to gray. So you can access the property and say document.bg color is equal to gray. These two things are doing the same thing. But here in the body tag, you're setting the background color of the body text to gray. Here we're getting at the tag for the document, we're setting it to gray. So we're using the object model to navigate, to change the attributes for the different components that are part of it. Everything is event-driven, however, so in real life, objects can encounter events. Events is some action that has happened. So we can identify an event that may happen to a web page. We can watch for the event to happen. One example might be to watch where the mouse is placed on the screen. And then we can have event handlers. So now we're going to give you the sort of the mouse over, the mouse move, where we can have an event, so we can have an image, a dog or a cat or something, follow the mouse around the screen. It's irritating people. So when you see an event happen, we can use a handler to the event. Such an event is a mouse over. So when the mouse is placed over an object in the web page, move the object. So you can't click on it. So the event can trigger an action, such as changing the picture that the mouse is over. Here's how we would do that. So our event handler is responsible for doing something when the event has happened. So here we have a anchor, which is a hyperreference, which is going to be a point in the page. So on the mouse over, document.background color is equal to green. And this is some text, which is what we're going to say. When you change the background color to green, when you put the mouse over the link, it changes the background color to green. So it's going to be on the event of the mouse on mouse over. And the on mouse over event is going to be tied to the text that's part of the anchor. This is just a placeholder if we wanted to call this particular event, this reference. We can go to the reference if we wanted to, but we're just basically giving it a number or giving an identifier. On mouse out event. So we can also make things happen when the mouse is removed from the object. So you put the mouse over a menu item, changes the image, take the mouse off the menu item, puts it back to where it was before, perhaps. So the mouse is removed from the object, like when the mouse is moved from one link to another or to a picture or something. It's known as on mouse out event. Works the same way. There's other mouse events as well. We also have variables that can be responded to in terms of the object model. So we've already seen some of the variables using sample programs. We can set the value of variables to whatever we want. We can use the values whenever we want to use them. So the variables can be reused as many times as we want in the program. And here's an example of how we would want to do that. Arrays. So an array is an ordered collection of data. So if we want to store 10 pieces of similar information in an array, it's easier than coming up with 10 unique variable names, which is why we use arrays in programming languages in general. So an arrays are indexed with a number. So here we have variable pets equals new array. So before I said new object, well, an array is an object type. So we can say new integers, new float, new array, which is a way of creating an object. And so we have pets, this is going to be the object. The object is of an array type, so we can say pets 0, fluffy, pets 1, sparky, which is basically the same syntax as what you get in C or C++, actually. The array indexes start with 0, they go to the size of the array. we don't actually have to say the size of the array. They're dynamically created. So arrays start with 0 and go from there. So some programmers like to start with arrays as 1, as they believe that this is the more natural or easier to understand. So as long as you're consistent, it doesn't really matter. It doesn't make a difference. Although I do prefer to start arrays with 0. Actually, you can start with 1 if you want to. If you just don't assign anything to 0, you never use it. So you just go array 1, 2, 3, 4, and then you can call back array item 1, 2, 3, 4. 0 is just empty. In fact, you can do the same thing with other programming languages as well. So remembering that methods are actions that are associated with objects. The actions are often triggered by events called in the middle of the program. So for example, document object has a method write, which takes on putting in information into the browser. So we've seen this before with the dot notation. Functions are methods. Methods are functions. So a function is a group of statements that have been collected together to perform a specific task. So they're grouped in such a way that you can be reused many times in a single program. So we call the function in the same way as we call a method, just by using the function name. So here's an example of the array objects. So arrays are supported as objects. So we can say length, attribute length, to get the length of the array. So here's methods also include concatenate, join, pop, push, reverse, sort. We can run array sort, and it will sort us for us. So here's an example of some of these. So variable A, this is our array, it's going to be equal to, and notice we didn't say new array. So arrays are objects anyway. So we can create it as an object, run methods on the object if we want, store information for the arrays that way, or we can just treat them like variables. So here we have variable A, and here's our array. So for I is equal to 0, I is less than A dot length. So we ran the method length on A. I plus plus, and then AI plus equals 2, add 2 to each one of these items in the array. And then we have B dot is equal to A dot reverse. So we can run, this is just a short list actually. Concatenate, concatenate array, put one array with another array. Join, push, pop, reverse, treat it like a stack, treat it like a queue, reverse it, sort it. So this one's using a reverse. It's going to turn around the order. A little bit more functionality than you get in some other programming languages. Many other predefined types of objects. So array is an object type, object is a plain object type. Strings are an object type, math, date, regular expression, numbers are objects. So we have some limits, conversion to strings, regular expressions, date conversions. You can manipulate all sorts of different methods for strings actually, in terms of object types. So other predefined objects also includes objects that are automatically created for you, which are always available. So we can get at, well, the navigator, we can get at the document we've seen, the screen, the window. So this is going to tell us stuff about our browsers, our navigator, our browser, our document, our screen, our window. They're predefined for us. The document object has many different attributes associated with it. So the current documents are available via the document object. Many attributes are available for the current document, the title, the URL, the form, the color. So some people use this to actually populate information out and say, this is the last time you visited, or here's the title of the document, or this is the document that you're on, or this is the one you're not on. So here's an example of using the method to print out. The output goes with the HTML text. So the plus is going to concatenate. It's going to say document.write. My title is document.title. And we know we can set document.title in the head section of the document. Puts the little title up on the menu bar. So we can see and keep track of everything. So you can actually write a pretty interesting spam program that keeps track in a cookie file all of the different documents that people have visited by keeping a list of the titles. And then, the user clears out their history and clears out their favorites and stuff. But you can still go back and take a look at that little file that you saved that you have used to keep track of it, and spy on whoever's using your computer to see what they're writing. So here's an example of a JavaScript. So we have JavaScript is fun, I'm a web page, and here's my name, document.write, document.title. So we can kind of see how we put the pieces together in the completed head section, and then the body section, and then we have the script down here on the bottom. So we can put a comment in here as well, and here's the comment. So sometimes you see this a lot, especially with troubleshooting. Like, the page isn't working, so let's comment out this part, and let's comment out that part. So the syntax is kind of interesting. It's the exclamation point goes at the beginning. So it's the opening arrow, less than arrow, exclamation point, dot. And you have to actually put in two slashes, two minus signs. And then if you put the exclamation point over here, it doesn't read it correctly. So you actually have to use the syntax. And this will create a document comment for you. Basically makes it unavailable. Treats it like text instead of... Actually, it doesn't treat it at all. Ignores it. So it doesn't render it. The browser doesn't render it. So here we have a function example, the keyword function that's used to define functions or subroutines that we've seen. So function add, taking on parameter x and y. It's going to return x and y. So it's a nice little example of a function. And then for events, we're going to have the event call the function. So it supports an event-driven handling system. So we can tell the browser to execute the JavaScript commands when some event occurs. Sometimes the resulting is that the value of the command determines the browser activity or the browser action that's going to occur. So here's an example of a simple event where we're going to set, looks like the background color at the beginning. And then we're going to put a little header up here that says, hello, I'm a very small page. And then we have a script. The script's going to be save the width is equal to the window.innerWidth, and save height is going to be the original height of the window, window.innerHeight. And then the function restore. So the function restore, when you change the window, it's going to restore it back to the height and width that it was on before. So window.innerHeight is equal to saved width, and window.innerHeight is going to be equal to save height and save width. So change the window size to be small. Window.innerWidth is equal to 300. Window.innerHeight is equal to 50. Document dot background color is going to be cyan. And then on the button, so this is the code here. Basically what we're going to do is open up a window. When the window opens up, it's going to take the current height and width and save it. And then there's a function defined here that's going to say restore. And when we call restore, it'll restore the window after we've resized it. So we can associate the buttons with the JavaScript events. And so we can say here on click alerts, we can actually run this method here. So on a button click, we can say restore. So change the window size to be small and then run the restore. And the restore would set the window size back. So a lot of people do it on the close, on window close, restore. So you can't shut the window down and you can't make the window smaller, which is kind of irritating as well. So everything good in here can be turned into something that's irritating. But usually you want to make sure, sometimes in some cases you don't want the user to resize the window. You can actually turn the resize off so they can't resize the window. And that's a browser window control. You can take the resize, disable the window resizing. Or if the user does resize the window, you can have a button that clicks that runs restore. That will take and restore the size of the window. Here's another button click activity. This is how you associate it. So you can associate the buttons with a JavaScript event. So this is the buttons in an HTML form. This is what we were looking at last time in terms of the forms. So we have the form, the input type button, the value don't press me, and then on a click event alert. Now you're in trouble because you pressed the button. So I'll put up a little alert box on the on click event. So on-click event is going to be on the form itself, on the button. And you can set an on-click event for each one of the buttons that you have. Some other events for a small sample, some of the other events for window events, on and unload, on a load, on a click, on a mouse up, on a mouse down, or link events, on a double click, on a mouse over. You put your mouse over and it pops up a little window that says, click here if you want to see more, or something. You ever seen those little dynamic help things show up when you hover your mouse over menu items? That's an example of that. What we're getting to is this concept of the document object model. So it's the naming hierarchy used to access individual elements in the HTML document. So Netscape document object model is a little different than the Internet Explorer. Netscape substitute that, put in Firefox, which is same equivalence. I shouldn't say that, but the modern day alternative browsers, Firefox for the most part, or Chrome, or Safari, many different browsers out there still. They're all different from Internet Explorer, which is a problem. Because then you have to test, okay, what navigator am I using? Internet Explorer. Okay, then I have a totally separate set of functions that I'm going to run for that one, if I'm going to use the document object model, than if I'm going to use Firefox or one of the other object models. which makes things a little bit complicated in terms of having to figure out, well, what browser are they using? And then now you have to consider mobile browsers as well, which is a slightly different object model as well. So a lot of people have steered away from the document object model in an attempt to make things more compliant among different ones. Don't use it, then it makes it a little bit easier. But older websites are still using it. And some newer ones are too. There's nothing wrong with using it. But it's going to be phased out eventually because it's not standard. It's hard to write web applications that work on all browsers. So it's easy to use if you name all of the entities, forms, fields, images, etc. Here's a DOM example where we have an ID, my form, an action, a type, and then from JavaScript we can get at an age input field by going document.myform.age.value. This is the object model where we're getting at the different elements from document. Still used a lot. I shouldn't give you the impression it's not used, but it's still used a lot in getting at items, objects that are on the page, and getting at their attributes or setting their attributes to something. Form field validation. Used a lot, actually. You can use JavaScript code that makes use of user enters invalid information or invalid information and can test to see if the information is correct. So because you want to test it on the client side because you don't want it to go to the server unless it's good information. So you can have the submit button is pressed. It can check, simple checks, a script that checks all the values, make sure the numbers are numbers and the text are text. So you can prevent the request from happening if there's no correct information that's being put in here. So checking the fields, here's a form check function. If the document.myform.ageValue is equal to nothing, alert, you need to specify the age. Now instead of an alert box, what they do, they color everything red. So take the label and make it red. The label says enter in your age, or put a little red asterisk next to it and highlight the asterisk in red. Otherwise it's white. It matches the background color. You don't normally see it. And then you use the document object model to take, make that color red. So you ever see it, you press OK and then it comes back and says, oh, all this red stuff. What is this red stuff? And then you fix the red stuff. So it needs to return true or false, actually, whether it's OK or not. So you need to prevent the browser from submitting, here you go, return. So on submit, return a form check. So run the check form function on a return, which means come back to the same page, process it, but come back unless it comes back with, the results that we need. So here we go, this is running a foo.cgi form, which is on the server actually. So it's going to return back to the page and let us know if we've entered everything incorrectly. Important note about form validation, it's a good idea to make sure the user has filled out everything before submitting it. And users can bypass your form. They can create requests manually on their own forms if they want to. So we have different pieces and things to consider. So I believe I'm going to stop for today because I see some bored faces here. I don't know. I see some tired people who can't sit for longer than an hour. It's only been an hour and a half. So next time we'll go over, and someone remind me, next time we're going to go over decision making. Using if, else, then statements and putting it together. And then I'll have some source code examples for you as well. So we can download and see it work in the browser. And then what we're really doing at this point is controlling the flow of the web page, which is a slightly different concept. So we will stop for today because it's lunchtime too. So someone remind me we stopped on decision making for next time.